Hey everybody, let's talk a little bit about naming some of these organic compounds. In order for you to name these compounds, we have to first be able to identify, typically, what we call the longest carbon chain. Okay. Once we find the longest carbon chain, then we can do some more in-depth naming. Now, if we're going to do that, we also need to then have some things committed to memory. And the things that we have to have committed to memory are the numbers, okay, that correspond to the longest carbon chain. So if you have a carbon chain that's only one carbon long, that prefix is meth. If it's 2, it's eth. Prop 3, okay, like propane. Propane is 3 carbons long, okay, and then we can go from there, okay. And so then butane, like in a lighter, that's a 4 carbon long chain, okay. So these 3, I'll put them at, whoa, hey, hello red, okay, which I kind of meant to do, but let's see. Let me just say that these 4 are the strange ones. After you get to 5 all the way up to 10, and even beyond, there's some for all of them, for all the numbers, but the first 4 are the ones that are a little tricky because we're not used to them. Although I would guess that you've heard of methane. Let's see, methane is a 1 carbon organic compound. And so, like, that's fine. And so ethyl alcohol, that is a 2 carbon alcohol, okay? And we talked about propane and butane. So my guess is you have some context for knowing these. And then once we get after 4, once we're after 4, then we have all the Greek prefixes, pent, hex, hept, octagon, and dec, okay? So I think that those are fairly straightforward. And now the ending, let's talk a little bit about the ending. So the ending, if it ends in ane, that means it's an alkane. That's kind of convenient, okay? If it ends in ene, that means it's an alkene. If it ends in ine, that means it's an alkyne. And this is true throughout the organic chemistry naming world, okay? Every part of a name in an organic molecule has some sort of meaning to its structure. Okay, there's no superfluous or extra letters or numbers. There's nothing. It's all systematic, which is one of the reasons why I personally really enjoy organic naming, is because it all makes sense. You put it together like a puzzle. So here's some examples. Okay, so let's talk a little bit about methane. So again, we're going to break it down into its parts. Meth and then ane. Meth means it's a 1 carbon chain, so there's our 1 carbon. And an ane means that it's an alkane, no double, triple bonds, all single bonds. And so we're going to put hydrogens around the rest of them. Okay? So that would be methane. Now, here's a structure of something, okay? So here's a 1, 2, 3 carbon. So once we do that, we know that it's prop. Now we look and see what kind of hydrocarbon it is. Well, I see a triple bond. Okay. Well, if it's a triple bond, it's a it's an alkyne, and so we're going to end that with Y-N-E, propyne. Okay, and now here's a 2 carbon chain, that's eth, okay, meaning 2 carbons, and then there's a double bond there, so that's a alkene, so it ends in ene, ethene, okay, and so a lot of these may make a little bit of sense, and that's kind of the point. Okay, now one of the things that can be a little tricky is finding the longest carbon chain. Now, keep in mind that single bonded carbons and hydrogens have free rotation. So here's the thing is that what we have to do is we have to identify the longest carbon chain, and in each of these, this is all the different variations of the ways that you can draw butane or a 4-carbon chain. Okay, we're probably used to seeing it like this. Okay, there's butane. But if we take this guy and now we spin this around, okay, so that now their carbon is up, notice we get this. Okay, and so this is still the longest carbon chain. So I think that the important thing to keep in mind is the longest carbon chain can be, and I don't know how official this is, but what you want to do is you want to draw the longest carbon chain, or you want to have the longest carbon chain, and you want to do that, you want to start with the carbon at the end, and then you want to draw, without picking up your pen, and without tracing back over, through as many carbons as you can, and then count them. That's 1, 2, 3, 4. Okay, that's how you take into account. Free rotation. Okay, and now if you take this guy, okay, it's almost like Tetris at this point. If you take this guy and just rotate him 180 degrees, he turns right into this guy. Okay, look, I can start here and I can do this. Look, so we have 4 carbons right in a row. And then if I take this guy and flip him over, like kind of flip him this way so that, okay, we can make this with 4 carbons here. Okay, so all these guys are kind of all the same thing. These aren't even free rotation things. These are just the same molecule, just written slightly different. Now here's a free rotation thing. Again, if I take my pen and put it here and then follow along, I'm going to follow along without lifting my pen off the paper or my tablet, and then I get 4 carbons in a row. Okay, now this can be challenging sometimes, because now if we look at the down here at the bottom, okay, finding the longest carbon chain can be maybe a little more challenging. Okay, the idea is, and I'm going to do a couple of these, so if you want to pause the not a couple of these, but I'm going to do this a couple of different ways. So if you want to pause the video and try it yourself, that's fine. And it's frustrating at first, but once you get it, you're like, oh, I got it. Okay, so let's take a look at this guy. Okay, the initial thing that people always want to do is they want to start here and they just want to go, okay, 1, 2, 3, 4, 5, 6. Okay, that's a hexane. I can tell you that is not going to be a 6 carbon as being the longest carbon chain. Okay, so let me get rid of that line. Okay, because let's see. I can start here and I can go 1, 2, 3, 4, 5, 6, 7. Okay, so I got up to 7. But I bet you I can go even further. Okay, let's erase that. Okay, so right now the longest carbon chain that I've made is 7. What if we go 1, 2, 3, 4, 5, 6, 7? Oh, that's the same. Okay, so that's not the right way. Okay. Now let's try, what if we do like, what if we start up here? What if I go 1, 2, 3, 4, 5, 6? Not 6. That's not good. Okay, you can see where I'm probably going with this though. Okay, because once you see it, it's hard to unsee. But I go 1, 2, 3, 4, 5, 6, 7, 8. That, folks, is the longest carbon chain. Okay, and that's where we want to go with it. Okay, now we don't have to go that way. We could also go that way, and that's fine too. Okay, but either way, the longest carbon chain there is 8. So we can try this one. Do the same thing. Okay, so 1, 2, 3, 4, 5, 6, 7. People want to stop there. But let's keep going down here. Here's an 8 carbon chain. Okay, let me try different ones in black. Let me put them let's put it over here. Let's see. So let's go 1, 2. That seems the same there. 3, 4, 5, 6, 7. Nope. Okay, 1, 2, 3, 4, 5, 6, 7. Nope. How about 1, 2, 3, 4, 5? Nope. Okay, it looks like with this one, again, the longest carbon chain is going to be 8 carbons. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Let me double check that I counted that right. 1, 2, 3, 4, 5, 6, 7. Okay, so all through that whole thing, I counted wrong. I had the right chain, but I counted wrong. Okay. Excuse me. So that's 7. So the point of finding the longest carbon chain is that when we name this now, this is going to be some sort of octane, and this is going to be some sort of heptane. Okay, we have to start by naming the longest carbon chain. Okay, so I hope that helps determining what the longest carbon chain is and doing some naming of some simple organic molecules. Okay, have a great day.